first you see today's problem is solve the linear programming problem. uh, Min z equal to means minimize z equal to 5x1 5x1 plus 3x2. First you see the question, solve the linear programming problem. Min z equal to 5x1 plus 3x2 such that twice x1 plus 4x2 less than or equal to 12, and then twice x1 plus 2x2 equal to 10, then 5x1 plus twice x2 greater than or equal to 10, and x1 comma x2 greater than or equal to 0. So here you see, first you see our problem is minimization problem. Okay, minimization problem. So first we convert it into the maximization. Okay, and next you see our all the here three constraint. So first constraint symbol is less than or equal to. Okay, and the second constant is equal to, and third constant is greater than or equal to. And you see this three constant part means 12, 10, again 10. So these are positive, so no problem. Okay, if negative, then first you make it into positive. So for the first constraint here, first work is what? Minimization problem. So first you convert it into the maximization problem, solve, and after finally again you convert into the minimization. Next you see the constraint constant term. So constant is positive, then no problem. Next you see constraint contains inequality symbols are what? Less than or equal to or equal to greater. So first constraint is less than or equal to. So for the first constraint we use which variable? For the first constraint?
Slack variable.
Slack variable. Okay. So for the second constraint we use which variable? For the second? Yes, for the second constraint we use here artificial variable. Okay, and for the third constraint we use here what?
Surplus variable and artificial variable.
Surplus variable as well as the artificial variable. Why we use? Then you will remember for getting the identity matrix or unit matrix. So first you see the second page. You go to the second page. So first I have written here. First we convert the problem of minimization to maximization problem by taking the objective function as in the second page z dash equal to minus z. So make z dash equal to minus z and you substitute the value of z. So z means mean z. So this is 5x1 plus 3x2. So this is minus, so minus 5x1 minus 3x2. Next one, what is given you see. Now equations obtained by just কি আছিলে অলপ পিছত লৈ লওঁ হা 15 কি কথা so just you see now equations obtained by introducing slack variable. So here we use for the first constraint we use the slack variable. So here we use x3. So you can for the slack variable you can use s1 also, no problem. Okay, so I have used here x3. So x3 surplus variable x4 and artificial variable a1 a2. Okay, in the given problem, then make z dash equal to minus 5x1 minus 3x2. Okay, and later I shall give why we have written here Then uh, twice x1 plus 4x2 plus x3 equal to 12. So x3 will remember x3 is our select variable. For the second constraint, we use the artificial variable a1. So twice x1 plus twice x2 plus a1 equal to 10. For the third constraint, 5x1 plus twice x2, and we use the surplus variable is minus x4. So x2 we can write 0 into x3, no problem. So minus x4. Same way we use here as well as plus a artificial variable a2 equal to 10. So you remember in objective function, when we use the select variable in the constraint in objective function, coefficient will be 0 into select variable. And when we use the surplus variable, then we use here plus 0 into x4 is our surplus, okay, but we use here also artificial variable a1 and a2. So for a1 we write minus capital M into a1, then minus capital M into A2. And M2, M is, you will remember, this is the large positive number, large positive, as you wish. There is no, we can take 1, 2, 3. Sometimes you take 1 crore, 2 crore like this. So this is maximum. M is positive. Okay, M value is positive. So for the first constraint we use here, you see, for first constraint this is x, select variable is x3, and for the second constraint only use the
Sir,
artificial variable a1,
sir, like,
and for the third constraint we use,
sir, for like
yes,
a
Sarvas?
a1 and a2 phi are we like multiplying them with m like phi not zero like how I mean phi are we doing that?
This is why not zero, because this gives us actually the penalty. For the penalty, actually this is called the big M method. Later I shall give discuss this one, big M method. So here when we use here surplus as well as the artificial variable or only artificial variable, there for solving this there will be some penalty. So this penalty is adjusted by some maximum value of M. So this is M. So this M is positive. So for this reason, only artificial variable we use here, not zero. This is by capital M. M is the penalty actually. Okay, that's you remember. Clear?
Yes, sir.
Okay. So, and name of this method is also called the big M method. BIG capital M method. Why? Because we use here the artificial variable and this is the penalty. Also, this one sometimes called this is the penalty method. So, sometime one linear programming problem is given and ask question, solve it by big M method or penalty method. Okay, so you will not confuse which one is penalty method. When we use artificial variable, then this is called the penalty method or big M method. Okay, so just here you see, you can identify for x3 we get first column of the identity matrix. Okay, for a1 we get the second column of the identity matrix, and for a2 we get the third column of the identity matrix. Okay, so here taking, so here total how many variable present here? So total how many variable present?
So six, I think. I
Six,
mean,
na? Okay.
yes, sir.
So here, which variable we consider equal to 0? Which variable? So use all of you see, for x3 we get the first column of the identity matrix. So x3 you cannot consider 0. A1 gives us the second column of the identity matrix, so we cannot consider this, gives us a A1 equal to 0. And A2 gives us the means third column of the identity A2 not equal to 0. So we consider here what? X1, so X1, X2, and here you see X4 also equal to 0. So here X3 equal to 12, then A1 equal to 10, and A2 equal to again 10. Okay, so in the table you just see we have written B, then CB, then capital XB, and here capital Y1 denotes all the coefficient of X1, capital Y2 denotes all the coefficient of X2, and capital Y3 denotes all the coefficient of X3, and Y4 denotes all the coefficient of X4, A1 all the coefficient of A1, A2 all the coefficient of A2. Okay. So Cj same as coefficient of the objective function of C1 means x1
Sir,
coefficient. Yes,
sir, why we are not
Nihal.
taking three artificial variables?
Three artificial we will not take. Why? Because why we use artificial variable? Artificial variable we take for getting identity matrix. Okay, so here you see in the first equation, without taking artificial variable we get the identity first column of the identity matrix without taking artificial variable. You see why we choose artificial variable for getting the identity matrix. So this is clear, Nihal?
Yes, sir, clear.
Sir,
Because you see,
sir, like,
uh,
why did we
yeah,
include A2 in the third equation, like artificial equation? I mean, in third equation, like we also
A2,
include, yes, sir, A2.
A2. So for third equation, why we use artificial variable? Otherwise, we cannot get the third column of the identity matrix. Can you get the identity matrix, third column, without using artificial variable?
No, sir, yeah. I mean, everything
Can you?
else will be zero. So, yeah.
Yes. So we cannot get the identity matrix because you see, then this one will be what? Actually, after this, you see, we get one matrix format. This table actually gives us the matrix. Okay, and here you see, then y1 coefficient is 2. Y1 means all the coefficient of x1. Coefficients are what? 2, 2, 5. Then y2 means coefficient of x2 is 4, 2, 2. Then x3 is means y3 column will be y3 column will be 1, 0, 0. Then y4 column will be 0, 0, minus 1. So you see 0, 0, minus 1 is not our identity matrix column, any column. Okay, our this should be 0, 0, 1, not minus 1. For this reason, in the third equation we use here plus a2. Okay, plus a2 artificial. So in a1 column is 0, 1, 0, no problem. A2 column is 0, 0, 1. So our identity matrix column will be y3, a1, and a2. So similarly, our basic variable will be y3, a1, a2. So y3 coefficient in the objective function is 0, means corresponding to x3, 0. A1 coefficient is minus m, and A2 coefficient is again minus m. So first table is clear or not? Anybody?
Yes, sir, clear.
Yes, sir.
Abhilasha? Clear na? Anuj? First table. Anuj Sharma? Arif?
Yes, sir. Yes.
বুঝতে পেরেছ? So,
So
so
you
you
see
see
here,
here. So,
So like
Next will be
so
Z
like I had
plus
a
two.
small doubt
Are you,
so like why did like why did we take like two artificial variables? I mean, is there a rule in taking artificial variables?
Arif mic off कर दे.
Arif, microphone to. Yes, Arbaj, yes.
Sir, I meant that why are we like taking two artificial variables? Like, is there a rule when we take artificial variables?
No, there is no rule. Actual, our rule is just we consider means our main aim is for solving linear programming problem. Our main aim is getting the identity matrix. So sometime what happen, you see, sometime without using means what, sometime artificial variable without using we get the identity matrix. Okay, in that equation if you use artificial variable then no problem will not be wrong, this will be correct, but your calculation will be lengthy means what, you means with the help of six variable you solve the table, then if you use another variable then seven variable means what, another column will be extended, seventh column. Okay, there is no rule how many artificial variable use or how many this, actually rule main aim is getting the identity matrix, because you see in the third column, third equation, in the third equation we cannot get the identity matrix. Okay, in the third equation you cannot get the identity matrix. This is clear?
Yes, sir.
Clear?
Yes, sir, it is.
Arbas? Okay. So if you do not use here A2, then you cannot get the identity matrix column, means third column. And without using A1, you cannot, in the equation 2, you cannot get the second column of the identity matrix. Okay. So next you see Z dash equal to CB into XB. So Z dash equal to CB into XB. So CB into XB will be what? Just you multiply 0 into 12 is 0, then minus m into 10 is minus 10m, minus again minus m into 10 is minus 10, means total 20m, same as earlier. Same way delta 1, delta 2, delta 3, delta 4, delta 5, delta 6 you calculate. Clear this one? Same as earlier. Delta 1 equal to C1 into CB into Y1. Clear? So you will calculate, and if you find any difficulty then you will ask, just you see. Next you see here which column will be this delta j are positive or negative, you see. So 0 0 0 no problem, then minus m, then minus 5 plus 7m, this is positive or negative, this gives us the positive value or negative value.
Positive.
Positive. Why? Because you see, yes, positive. Why? 7 into m. M is large positive number. Okay, 1 crore, 2 crore, like this. So this gives us a positive value. Again, minus 3 plus 4m. So this also positive. But here maximum one will be what? Here you see its coefficient is 7 and its coefficient is 4. Okay, so obviously minus 5 plus 7m is positive. Maximum means maximum delta J value. So this is our incoming vector. So you see this is clear or not? Ishita, Binoy, Dipanshu.
Yes, sir.
Yes, sir.
So here you will not confuse. Yeah, minus 5 plus 7m, this the one how to this gives maximum delta J value because minus 5 and here plus 7 into m. So you m consider 2 crore like this. So this gives us positive. Then minus 3 plus 4 into same value consider. So obviously 7m coefficient, this is maximum delta J. So this is our incoming vector. So if this is the incoming vector, then minimum ratio equal to xb by y1. So same way, see, 12 by 2, 6, 10 by 2, 5, and 10 by 5 is 2. So 2 is minimum, so this gives us the minimum ratio row. So A2 is our minimum ratio row. So pivot element will be 5. Clear? So in the second table, you will remember, so outgoing will be artificial variable. Means A2 is our outgoing vector. Okay, so here in the next table you see a2 will be out and a2 will be replaced by incoming vector y1 remaining as same, and third row is divided by pivot element means 5, so we get 2 1 5 0 minus 1 5 minus 1 by 5 0. And then in the second table you see, all of you see, I have not written A1, A2 column. Okay, I have not written A2 column. So you remember, if artificial variable is I outgoing vector, then next table we will not write this column. We delete forever. So this line is important one. You can write note also. If artificial variable is outgoing vector, then we will not write for the next table. This column will not come. Okay, but artificial variable is not out, means not outgoing. Then you write. But here A2 means artificial variable outgoing vector. Then we will not write in the second table. Up to A1 we write. Okay. So this is actually the procedure for solving BCAM method. When we write the procedure, then you will get this line. Okay. So for the second table, same as earlier procedure, how to find out the new element. So new element equal to old element minus intersection of key row key column divided by pivot element. Okay. So second table calculation you will see. Okay. So calculation part is clear or not? How to calculate the new element,
Yes, sir.
Dipanshu? Arba's clear, no? Okay.
Yes,
So calculation part you see, anybody you have doubt, then you will ask. Okay. So after calculation, we get this one. Again, you find out z dash in the second table. So you see minus 6m minus 10. Again, delta j value. So in delta j value, we already calculate, and here you see 6m. So 6m by 5 minus 1. This is one positive term, and 2m by 5 minus 1 is another positive sum. So here 6m is highest coefficient of m is 6. So this one will be what? Our incoming vector. So minimum ratio will be xb by y2. So this is, you find out minimum 5 by 2, 5, 5. So 5 by 2 means 2.5. So first row of the second table is our minimum ratio row. So y3 is outgoing. So similarly in column I have given outgoing same. Okay. So pivot element will be 16 by 5. So in the third table, you see similarly, you divide this by 16 by 5 and y3 will be replaced by y2. So in the third table, you see y2, in place of y3, I have written y2 and remaining are same. And calculation, same way, you get the third table. And then in the third table also, you see here this one is our means uh, third table z dash equal to we get minus 25 by 2 minus 3m. and delta J value 0, 0 minus 3m by 8 plus 5 by 16. So this is also negative because minus 3m, m is very large. So plus something, no problem. Okay, by division, no problem. So this is negative value. But m by 4 is positive. M is very large, minus something. So this is very small one, 7 by 8. So this is our positive term. So this is our incoming vector. So this is our incoming vector. So minimum ratio will be in our table xb by y4. So after calculating this one, we get 20 and 12. And third row, this is our negative value, we will not write.
Sir,
So
sir,
similar,
sir, when the
yes.
artificial variable are outgoing, why do we remove it from the table? I mean, is there a reason?
The reason is what actually artificial variable, if artificial variable is present in the after solution, if it present in z dash calculation, okay, then this does not gives us a solution. Okay, and actually what happened after calculating this one, if outgoing is our artificial variable, then in the next table there is no rule for the artificial variable if outgoing. If not outgoing, then this activates some rule, but this is if outgoing, then this is not a means what, this is not activate any role. So this will be out means we consider this is means outgoing means we will leave this column forever. Okay, so just you remember this one in z dash, suppose z dash contains, suppose after all delta j is negative and z dash contains also some m value present, then we cannot say that this gives us a optimal solution. So for this, if outgoing, then we will not consider this, means we leave this one forever. Okay,
Okay, sir, and
Arba?
another question. In the third table,
Hmm.
in the
Hmm.
Y3 and Y4 column, the delta J value is there. Like, I'm confused on like which one is smaller. Like how does the M
Smaller.
calculation works? Yes, sir.
Okay, so just you see the third table, na Y3 column and Y4 column, na
Yes, sir. So the delta
Y.
J part, I mean the minus 3m divided by 8 is there, and then in the other column
uh,
like is there, like how the calculation works. I'm confused about that part.
अच्छा, uh, calculation, अच्छा, 3 minus 3 8 by minus 3 by 8 into m. If m is large value, so its coefficient is minus. Okay, m is suppose 10,000. So minus 3 by 8 into 10,000 like this. Okay, or 1 crore. You consider 1 crore or 2 crore like this. 1 crore. So minus of this plus 5 by 16. So this gives us a negative value. Okay, you cannot consider m equal to 1. Very large value. Okay, and similarly you consider m equal to same, suppose 10 crore if you consider m in the y3 column, similarly 10 crore you consider in capital M in the y4 column.
So
So
like
these
we have to
divided,
make sure that the M value is same for like both of the calculation, right? So that there's
yes,
like
yes, m value will be same, but you consider this is very large, this is penalty actually, very large.
okay, sir.
Clear?
Yes, sir.
So when negative value, then this is will be negative. Okay. So obviously this one will be outgoing will be y4, incoming is y4 and outgoing will be artificial variable column a1. So here in the fourth table also you see artificial will not write because its activity is complete here. Just you remember, means in a1 is outgoing, so we will not write in the next table. So remaining portion will be this a1 will be A1 will be replaced by Y4. So Y2, Y4, Y1 in the fourth table means A1 is replaced by Y4. Actually, our aim is what? Actually, in BGAM method, our aim is to eliminate artificial variable from the basic variable. Our basic variable means capital B column gives us the basic variable. So our aim is what? From here, you eliminate the artificial variable is present. Our aim to eliminate. If we do not eliminate, then you will see in Z dash some term of M will occur. So if some term of M here present, then this does not give us an optimal solution. So in the fourth table, you see anything. Just you submit. So here z dash equal to what? Here you see z dash will be minus 23. Okay, so just z dash equal to cb into x, the same format. Okay, z dash is cb into xb. So cb into xb just calculate. So z dash equal to minus 23, and delta j value will be 0, 0, minus 1, 0. So after calculation, all delta j is what? Less than or equal to 0. Then we get an optimal solution. Okay. So next page you see here optimal solution means what? Our variables are what? Here the original problem contains two variables. So this is x1 equal to 4 and x2 equal to 1. And no need to write a1, a2. I have written here a1, a2. So you will not write this a1 and a2. Okay. A1, A2 will not write. Here A2 I have written this. A2 is total. A2 is also 0, not 12. Okay. So, but better you will not write A1, A2 because no need A1, A2. And make Z equal to then minus Z dash. So Z dash value is minus 23. So minus minus plus, so 20. So you see in this problem any doubt? Here just you will remember one thing, if artificial variable is outgoing vector, then we will not write in the next column. This is the major part. Okay. And one thing you will remember, sometimes if we do not eliminate artificial variable from basic variable, okay, then this gives us no optimal solution. All delta j is negative, all delta j is negative, but here in basic variable some artificial variable is present, then z dash equal to minus suppose 23 into m or 23 plus m or minus m, so present, then you say this does not gives us an optimal solution. So this is actually, this is called linear programming problem solved by bgam method. Clear?
Yes, sir.
Roshni?
Yes, sir.
Jonali? So
Yes, sir.
all of you try to solve this. Write in your copy. And one thing, A1 and A2 value will not write. A1 is 0 and A2 is, I have written 12. This is not 12. This is 0. If you write, then write A2 0 because A2 is totally absent. So A1, A2, no need to write. And only we require X1 and X2. Okay, so just response your name